Class we are discussing about the classification of power amplifiers. The power amplifiers are mainly classified depending upon the Q point. Okay, so first considering the output characteristics of CE configuration. So VCE versus IC. And this is for IB1, IB2 and IB3. So this is Q point. The power amplifier is said to be class A power amplifier if the Q point is approximately at the middle of the load line, DC load line. Okay, if the Q point is approximately at the middle of the load line, that power amplifier is said to be class A power amplifier. In class A power amplifier, the IC current, IC means output current, the output current flows full 360 degrees. It means it reproduces the input signal without any distortion. Okay, so here we have to draw . So this is the standard diagram you have to learn from power amplifiers. Vmin, Vmax, Imax, Imin. For class A, the first point is, the Q point is approximately at the middle of the load line. So this is the first important point, and the second one is the collector current IC flows total 360 degrees. And the third point is here for all the input values for all the input signal, the transistor remains in the active region. Okay, so these are the important points for class A power amplifier, and it can be represented with waveforms. So considering the waveforms, IB is the input current, IC is the output current. The collector current flows total 360 degrees. Okay, this is IC, and the third one is VCQ, the negative phase. So these are the output waveform for class A power amplifiers. Okay, next. So the same output characteristics VCE and IC. Load line. If the Q point is shifted to the x-axis, that power amplifier is called class B power amplifier. Okay, if the Q point is shifted to the x-axis, that power amplifier is called class B power amplifier. Okay, so here the point is, Q point is shifted to x-axis, and here because of this Q point shifted to x-axis, the IC current flows only 180 degrees. The IC current flows only 180 degrees, and the transistor remains in the active region for positive half cycle. The transistor remains in the active region for positive half cycle, and it enters into the cutoff for the negative half cycle. For the negative half cycle, it enters into the cutoff region, and the diagrams are here for this waveform. So this is the input cycle IB. For IC, for the positive cycle only, the transistor remains in the active region. So we get only 180 degrees output. This is the 360 degrees, and here we get only 180 degrees output. IC current flows only for 180 degrees. That is for class B power amplifier. Okay. And the next one is if the Q point is shifted to below the x-axis. If the Q point is shifted to below the x-axis, that amplifier is called class C power amplifier. Okay. Here this is the diagram IC VCE. If the Q point is shifted below the x-axis, that amplifier is, the first point is Q point is shifted to below the x-axis. Okay. And the next, here the IC current flows less than 180 degrees. And the transistor enters into the active region. The transistor works in the active region less than 180 degrees, and the remaining stage it enters into the cutoff region. For this, the waveforms are, this is IB input current, full cycle 360 degrees, and the output current IC is so less than 180 degrees. So this is the waveform for IC. Now VCE IC. If the Q point is shifted above the x-axis but below the middle of the DC load line, then that is called class AB power amplifier. If the Q point is shifted above the x-axis but below the middle of the DC load line, that amplifier is called class AB power amplifier. For this, considering the waveforms, so here here for class AB power amplifier, the Q point is above the x-axis but below the middle of the DC load line. Okay. And the IC current flows, IC current is nothing but output current. The IC current flows greater than 180 degrees but less than 360 degrees. Okay. And the waveforms are for class AB power amplifier. So this is the input IB, total 360 degrees. and the collector current is like this, IC. So greater than 180 degrees but less than 360 degrees. So that amplifier is called class AB power amplifier. For summary, we considered class A, B, C, AB. Okay. So for operating cycle, for class operating cycle, it produces 360 degrees, class B 180 degrees, less than 180 degrees, greater than 180 degrees and but less than 360 degrees. So the collector current flows for class A, B, C and AB. So coming to the next, the point of Q, quiescent point, middle of, approximately at the middle of the load line. For AB on x-axis, below the x-axis, and here above the x-axis but below the middle of the load line. So that is the position of Q point for different amplifiers, power amplifiers. And the third one, efficiency. Coming to the efficiency, class A power amplifier is very poor efficiency and it is somewhat better. High, class C power amplifier have high efficiency. For AB, it is higher than AB but less than B. Okay. So it is approximately 25 to 50%. It is 78.5%. Okay. And the last, distortion. Coming to the distortion, it produces the collector current 360 degrees. So no distortion for class A. No distortion for class A power amplifier. Here distortion is present. For class C, higher distortion, and for AB, distortion is present. So considering the waveforms, in class A power amplifier, we get the IC current flows total 360 degrees. So for class A power amplifier, there is no distortion at the output. For class B, the IC current flows only 180 degrees. So here the distortion is present. For class C, the IC current flows only less than 180 degrees. The output signal is completely lost. So in class C, high distortion is present. In class AB also, the distortion is present. Thank you.